pull up my about me page on there. I'm in the Microsoft Federal Civilian. I've been at Microsoft for most of the last 9 years in various roles. I think this is probably my 5th role at Microsoft, and it's always been around data platform and AI. And the latest role is just a different industry within Microsoft called federal. So US government and military and DoD and any government agency and whatnot is the clientele that I deal with. And I have been in IT for 35 years. I was talking to somebody today going back to COBOL and Turbo Pascal and MS, what was it? MS-DOS had BASIC on there. So I've been at times a developer. I was a DBA for about a dozen years. I've worked for various different companies. I worked on my own, and I do a lot of talking about this particular topic. In particular, the last 6 months to a year, it's been crazy. Every week, pretty much, I'm talking to customers 2 or 3 times a day about data architectures because there's a lot of confusion out there. It's in particular with data mesh being a popular topic, very popular topic of late, and then data lakehouse, and what does that mean compared to data fabric and the modern data warehouse. So I'll hopefully clean up some of that today. There are a lot of what I talk about is on my blog, jamesserra.com, and I'm coming out with a new book on this very topic. So look for that in a couple of months. But I'm always happy to have this presentation and help to answer some of your questions too. So along the way, I will stop and open it up for questions. You can raise your hand, you can put stuff in the chat, and I'll be paying attention to that. So hopefully I'll get to most of your questions. If not, you saw my email, jamesserra@gmail.com. Feel free to send me any follow-ups in there. So the agenda for this is I'm going to talk briefly about data warehouse and data lake. I go into this assuming people maybe know a little bit about a warehouse and a lake. And so I want to clarify what those are. And then we get into architectures, starting out with the modern data warehouse and then the data fabric and data lakehouse and data mesh. And I always got to say, these are my opinions, not Microsoft. So if you hear something here and you go back to your coworkers or your managers and say, Microsoft said this, no, it's James Serra said this. So it may not align with Microsoft's official stance, even though we don't really have official stances. But just because I work for Microsoft doesn't mean I'm representing a Microsoft, because some of these opinions can be controversial. All right, so jumping into, oh, and by the way, this deck I'll make available. I'll right afterwards. I'll send it out so everybody has a copy of it. The first slide, this has been around for probably a dozen years when I talk to customers about building a data warehouse. And it's pretty much been the same when you think about why have a data warehouse in the first place. So there's a lot of reasons to this, but I also keep this slide in here, even for people who know why you need a data warehouse, is because of copying the source data. You're still going to copy it. So one of the many misconceptions about some of these architectures, in particular the data mesh, is that, oh, you don't need to copy the source data. Well, you still do. And there's many reasons for that. The biggest is reducing that stress on the production system in there. So you don't want to have all these ETL or queries or reports going against the source system, because you can get angry end users who are trying to do updates, deletes, and inserts, and reads are not allowed to do it because somebody's running a query that's overwhelming the system that has those OLTP applications on there. And then you get into reasons like copying the data and renaming the fields and the tables because of what they're named in the source system can be very difficult to follow. I remember an ERP system that I used to work with, everything was numbers, T116, T109 on that. So trying to get reporting off that was nearly impossible. So copy it over, rename all that stuff, combine it with other data on there. And this is where, when you get into big data, the idea is we want to take data, no matter the size, the speed, and the type, and put it all in a central location. And rename it and join it and aggregate it and do all these things to make it very easy for the end user to then generate queries and reports off of that. There's a lot of data cleaning that's going to go on when you do that, even though customers have said, oh, our data is perfectly clean. And I always bet $100. I say, I guarantee I'm going to find some problems in there. And sure enough, we get in there and there's people with birth dates in the future or people with birth dates 200 years ago. And so there's all these ways that people get around having to put data entry in there. And that comes out when you build a data warehouse. And so copying the data also reveals those issues that need to be fixed, and this before you get accurate reports. And in the end, when you make all this copy in the data warehouse, you're getting this one version of the truth. So everything you want is going to come from that single area that you have this data. And so, okay, great. We want a data warehouse. We'll get into types of data warehouses in a little bit. Another popular concept that came out about 10, 11 years ago was a data lake. And quite simply, a data lake is just a glorified file folder, no different than what you have on your laptop on there. It's got more features when you're using the cloud. If you're using Azure, you have all these additional things on there for disaster recovery, you have availability, object tiering for saving money. So it goes a long way in getting the performance and features you need when you're trying to collect all this data in one location. That could be massive amounts of data. And so, well, why would I want to have a data lake and not just a relational data warehouse? And when I say data warehouse in the previous slide, I'm referring to if you're familiar with something like a SQL database, a SQL server, a relational database that has its own relational storage and its compute on top of that, as opposed to a data lake, which is simply storage. And the idea with a data lake is there are many benefits of using it in conjunction with a relational database. So if I have a relational data warehouse and I don't have a data lake, I'm usually have a maintenance window at night, and I kick everybody off the system. I copy all this data into staging tables in the relational data warehouse, and I do all the transformations. And I have to kick people off because it takes a lot of processing power to do all that. And then cross your fingers that everything gets done in time. The data then copy from those staging tables into production tables, and you can allow people back on. And if something went wrong, then you have a lot of angry end users on there. So at the very least, where a data lake comes in is think of taking those staging tables off of the relational data warehouse and putting them in a data lake. And I could copy all this data into a data lake, which is schema on read, meaning I don't have to do any upfront modeling. I could just land data in there like a file folder environment, and I can then have compute go on top of that and clean that data and land it back into the data lake. And then instead of having this maintenance window that's all night long, I have a very brief maintenance window, maybe a few minutes, where that cleaned and transformed data then is copied into the relational data warehouse and put into production on there. So that allows me to have essentially a 24/7 data warehouse where people can continue to do queries and reports because we're not colliding with doing data loading and transformations of the data. And so that's one big reason customers will use it. And to expand on it even more is, first, I have unlimited storage in a data lake. And if using it in the cloud, it's endless, which you don't have in a relational data warehouse. So chances are you're deleting stuff. So imagine you don't have a data lake, you copy data in there, and then the next day you realize, oh, wait a minute, something was wrong with that data. There was a bug in the ETL. I need to go back to the source system and retrieve it again, which you want to avoid because now you're stressing out to the source system. With the data lake, you can put data in there and keep it indefinite because it's so cheap relatively. So you can always have it as in case of a backup on there. You also have this data that you want to transform. You have the option of many different compute that you can put on top of that. So if you're in the Azure world, I can do everything from Synapse serverless to Databricks to HD Insights, if people are still using that. And I can use different types of compute as much as I want. And it's usually much cheaper than what you have in your relational data warehouse in there. So if I want to spend more money in return to get data clean more quickly, I can do that. If I want to save money, I can do that on there. So you have this ability to avoid the maintenance window and then save costs at the same time, or use more compute power if that's needed for the data that you're pulling in there. And then the last thing I'll mention, and there's a whole list of stuff I can go on and on about why I have a data lake, but the other big one too is that because it's schema on read, I can land data in there quickly, as opposed to when I was a DBA, you'd get end users who would say, hey, this data, it's really valuable. Can you copy it into your data warehouse? And so you go and you create a database and tables and fields and make sure you have the right data types. And then you write all the ETL. And then after weeks, sometimes you go to the end user, hey, I finally got your data in the data warehouse. And then they come back to you the next day and say, oh, it turns out that data is not valuable. I was wrong. Sorry about that. And you wasted all this time. Well, now with a data lake, you can land data in there, not do any of that work, and then have a power user or somebody in IT quickly go and query that data to see if it's got value before you go to that extra step of putting it in the relational data warehouse, if that's where you want to end it up. So that schema on read could be very beneficial, especially for data scientists. They like files and folder formats on there. So you can land it in there and they can quickly go and start using the data. So you're not bottlenecking IT with having to go and do all this upfront work. So in the end, when we look at having both a data lake and a data warehouse, is we have the separation like this. And this is the way most customers do it when we get to the modern data warehouse, which we'll talk about in a little bit, is the data lake can be your staging and prep area. And then your data warehouse could be that serving, security, and compliance area. So you're trying to get the best of both worlds in this environment in there. So as I explained, the data lake can be all that staging and cleaning of the data. It could be for power users to go and maybe just run a one-time report on that, or see or explore the data, see if it's got value in there. A lot of times it's used for exploration if you're not quite sure the questions to ask. I got this data, I think it's valuable. Let me go and play around with it and see. And if it is valuable, then maybe I will take the extra step of move it into a relational data warehouse, but you don't have to waste time trying to do upfront work in order to see if it's got any value in there. And then the data warehouse becomes a copy of some of that data, usually not all of it, but some of the data in the data lake moves to the data warehouse for things like faster performance, which you can always get against a data warehouse, especially one that's using some advanced technologies like MPP, massive parallel processing. And it's also going to have the benefit of having that metadata layer on top of the data. It's forced layer, so that could be a lot easier for people to find the data when it's in a data warehouse because the work's done up front for them. And then also a big one is security. The data lake doesn't have a lot of security things that you see in a data warehouse. Has been around for years, like row level security, column level security. You can do that in a data lake with a lot of workarounds, but a lot of times customers say, look, it's just easier to copy everything into the data warehouse, put the row level security on there, and just don't allow people to go into the data lake. We'll use it just for the cleaning of that. So this is a separation of the data. This has been changing, as you'll see when we get into architectures, but for the past, I would say, half a dozen years, customers have been using both the data lake and data warehouse and splitting it out in this type of functionality. So I'll pause there. Any questions? I don't see anything in the chat. Feel free to come off mute if you have any question at this time. All right, we're good. So let's jump into the first architecture. This is the modern data warehouse. This has been around, I would say, probably for the last 10 years with the combination of a data lake and a relational data warehouse in there. And when I talk to customers about this, I always break it out into 5 steps to pull in data into this architecture. The first is you're going to ingest it. And in green, I put Azure products in here. You can easily substitute this for any other cloud. And the idea is you're going to ingest all these sources. It could have dozens or hundreds of sources. into step 2, which is a storage, which in Azure world is Data Lake Storage Gen 2. And that is where you have your data lake. Now, the data lake is divided up into layers. And I have 5 layers or 4 layers presented here. Most customers, companies do it the same 4, but they just call them different names. Databricks has their silver, gold, and bronze, silver, and gold that they call them there. I don't like that because I like to tell it what it actually does. And in this case, we start out with the raw layer, which is just a copy as is from the source system, landed in the raw. Now, this is usually where data scientists like to play. They just say, give me my data in raw format. My data scientist has that really bad drawn hat, and he or she is going to pull that data from the raw layer and create machine learning models off of that. Most other end users are not going to want it in raw. They want it clean. So this is where we get into step 3, which is to take compute, which could be data factory, data flows as a compute, or it could be Datarex, it could be Synapse serverless. There's dozens of compute that you can put on top of this because most products now support a data lake and can therefore connect to it, pull the data out of raw, clean it, and then write it into a clean layer. And that usually is still not enough to get it to the point where end users can start using it if they choose to use data in the data lake. You'll go from the cleaner presentation where you again use those same compute technologies to do things like, well, maybe I need to join some of these files together. Maybe I need to aggregate some of this data. Maybe I need to create a star schema. And you land it into the presentation layer. And you also may have a sandbox layer, which is a copy of the data that maybe a data scientist wants it because they want to modify it and do things with it. Maybe multiple people want to play with the data, so you create all these sandbox environments. Because the data lake is so cheap in cloud storage that you're able to do that, something you can never do with a relational database. So the data could be sitting in a presentation layer. However, that in many cases is still not enough for end users to go and make sense of the data because of the file format structure. And the problem is the metadata in something like a data lake could be anywhere. It could be in a separate file. It could be within the file itself. It could not even exist. So it could be very challenging. This is changing with new technology, but it still can be very challenging for somebody who wants things very simple, self-service BI. You're going to want to go to the next step, and that is model the data. And step 4 means copy that data from the presentation layer into a relational database management system, like a SQL database, like a Synapse. And you copy it into there in third normal form, usually as it starts out, and you may go one step further and copy it into a star schema to reduce the number of joins that are needed, and to make it very easy for step 5 for an end user using something like Power BI to visualize the data. They can simply connect to this, what could be a star schema sitting in a relational database. It could be Synapse dedicated pool, and they just start dragging fields across on a workspace to create their reports and dashboards on there. So what has happened is you can say, well, it's a lot of work. It's more ETL, it's more cost, it's more complexity, which is all true. The benefit of that is you have the data in a format that is very easy for the end user to build reports without bugging IT. And that's where we have this trade-off. And this is where it's getting into a gray area where we're trying to reduce the number of copies with some of the technologies we'll talk about. But in the end, there's no silver bullet. There is no architecture that makes it easy to have a quick solution on there. It's always going to be a lot of work. Data warehouse always has been and always will be, despite a lot of companies saying, oh, we can make it easy for you, we can create shortcuts. They can do it to a various degree, but it's very minimal. You're still going to have to put a lot of work in. For example, data lake design is something I sometimes spend a whole day with a customer just talking about. How do I organize the layers? How do I have folders within there? Because maybe I want to do it for performance or for security or for governance on there. There's all types of reasons, and you have to think through all of this and understand the data that's coming in, the size, the speed, and the type. So you create something that's going to last a while. You don't want to go a few months in and go, oh, wait a minute, I didn't think about this particular data source. What we have is not going to work. Now we have to go back to the drawing board in there. So this is the idea of spend a lot of time. This is part of it. If you learn about all the architectures in there, you can narrow down and say, oh, what James talked about, this one particular architecture I think will work for us. Now let's focus on that and then go to the various pieces in there and design it up front so we build something out that's going to last quite a while. All right, let's see, we do have a question, I think. Yes, how does a data lakehouse compare in cost and performance to a data warehouse? Well, that's coming up. So stay tuned. That's a good segue into when we get to data lakehouse, and we'll talk about that. And then can a business-friendly data model, a semantic layer, it's a good term to have is think of a semantic layer as a business-friendly data model. Can it exist in a data lake? Well, yes, but you have to do upfront work. So the idea could be I can take data in the clean layer in a third normal form, and I can then create a star schema and land it into a presentation layer. Now, it's in files. So this is where the complexity comes in there. Can an end user go and see the files in there and attach to the Power BI and create reports? Usually not. So you have to put a relational layer on top of that, but that doesn't mean you copy it into a relational storage. You just put a layer that could be a view. So what a lot of customers are doing is they create a view, a SQL view that points to the file in the data lake, which could be a star schema. And in that view, it could be pointing to multiple files. And you could even add some metadata on top of that in the view. And then the end user can use that view, which is a semantic layer, inside of any report that they want to generate. So what the great thing about that is they don't even realize, the end user, that it's a file in a data lake. They think it's a relational database because it appears that way. But because you put that relational layer on top of it, you've made it a lot easier for them. So again, it's the trade-off. It's somebody's doing the work, but the benefit is self-service BI. Okay, another question. What are some of the best practices to implement data governance in a modern data warehouse? Data governance, that could be another big topic that as a customer, you want to spend time on developing and thinking through it of that. And one of them, what I usually recommend to customers, they create some sort of center of excellence for data governance. And that group will be responsible for the security, for things like data quality, for modeling the data, for even defining how data is going to be cleaned. You want to have standards. Everybody's either got to create U.S. states in two-letter abbreviations or the full name in there. So things like that can really mess you up if you don't have those standards in there. So you want to have that governance in place on there, or else it's going to be chaos when you start going and building stuff out. Now, there are tools that greatly help this way. In Microsoft world, they have Purview. You have tools like Calibra and Informatica, are all designed to scan what you've built and come back and tell you you have sensitive data. You can add some business rules in there to be alerted when people put in PII information in there. You can request access through these front doors in there. You can prevent duplication of effort because you can go to this data catalog and find out if data has already been placed in there that you need, or maybe reports have already been created, so you're not reinventing the wheel. So a lot to think about when you talk about data governance. All right. Good questions. I'll come back to some of them in a minute. We'll keep popping them in there. So the next data architecture is a data fabric. Confusing with the way others have defined data fabric. In particular, Gartner's definition is something that is about automation and AI and ML models to help with your data fabric. I don't agree with that because I've never seen a customer implement that. So I take a more basic, simple definition of data fabric, in that it's just adding additional features to what I just described as a modern data warehouse. So if you look at when you look back at that diagram, I didn't have things like real-time processing. So if you start getting into that, which is additional feature products you'll have to incorporate on that, when you start adding that feature, when you add more about data access and policies on there, so you're defining more ways people can access the data, but you have to have more security on top of that. So you're starting to add a complexity on top of the modern data warehouse. A metadata catalog, like I mentioned, Purview, you start adding that into your solution, which also tracks the lineage. So it's a great thing about a product like that is if an end user says, where did you get this value in this report? Your metadata catalog can go and show you a complete lineage that, hey, it came from this source system, we copied it here, we aggregated it, we put it in here, and then you have that full lineage, so you can, that end user can be confident that the answer was correct in there. When you start adding things like master data management, which is creating golden records on that, this comes into play a lot if you're pulling a lot of source data and some of that source data has customers and there are duplicate customers in there. Well, I can clean it up easily if the customers happen to have the exact same name and address, but chances are they don't. So you need to have a tool, an MDM tool that can go and look at all those and compare them and find out who, in fact, is the same person, and then filter them all out so you have one golden record and all your data is attached to that one record. Because the last thing you want to do is come out with a report and the first thing a user sees is, well, why is this person on here twice? Or why is this company listed twice? Or why is this product listed twice when it's the same thing in there? You lost their confidence right from the beginning. So MDM is a important part of a solution when you're looking at data warehousing in there. Data virtualization, the ability to query data without copying to a central location. When you start getting that functionality in there, you start getting into that data fabric in there. And then APIs. A lot of customers will create APIs in order to access the data. So instead of giving somebody a connection string, you can just say, any data you want, just call this API, here's the parameters in there. So building out that way is adding additional functionality to make it a data fabric. And then finally, you can build out a data fabric in pieces and blocks so people can reuse those pieces and some other part of the company in there. So maybe they look at your data fabric and say, well, I can't use your data fabric, but there's a piece of it, like your data ingestion piece, that I would really love to have for my product that I'm building on there. So if you build it out the right way, you could create a service that they can use, or you can make them copy the code because it's been made to be used for general in there. So in the end, data fabric is additional technology that creates a fabric. It's something that can go weaving out and collect all the data in your company, no matter where it's located or the size of it or how fast it's coming in, the speed or the type of the data. It could be CSV, JSON, and all that. So data fabric is simply a name for a newer generation of a modern data warehouse. So some people will call it a modern data warehouse data fabric on there. So this is where we get a lot of confusion. And
James, look like you got muted.
Well, hopefully I wasn't muted long. I think somebody pressed the mute all and it got me.
Yeah, not long really, just a few seconds.
Okay.
Yeah.
So those 2 seconds were probably the most important things I said no, I'm just kidding. So so in the end, data fabric is just a better, improved version of the modern data warehouse, according to my definition on there. Okay, any questions you want to come off of mute on there? Let's see what we got in the chat. Thomas said, can schema on read function dynamically without metadata reference? Yeah, but good luck without having a metadata reference on there. And this is the problem with the data lake is it's not a requirement to have metadata on there attached to data on there. So people can just start dumping all sorts of data in your data lake, and that's when it becomes a data swamp, because you can go like, I have no idea what this is. It's a CSV file with a bunch of numbers and commas in there. Nobody even put a header in there. So this is where we really struggle. Even when we get into the Delta Lake, which I'll talk about in another minute, it's there's no enforcement of that. So there's no automated enforcement of that. You have to have procedures and processes in place that people got to look at and see that you've included the metadata, but because the metadata and the data are not locked and forced like it is in a relational database. That's probably the biggest struggle people have with the data lake, is where is the metadata? All right, anything else? Let's see. Can you elaborate more, Robert said, on the data fabric definition from Gartner? Why is it not realistic? Because as an example, their definition is that you can create a data warehouse solution that is going to automatically find your source systems that are new and incorporate that into your data fabric. And I say, good luck with that. No, there's no tools out there that can automatically find stuff for you. It also goes into more of that. It can automate the metadata of finding all that. It could automate the ways data should be combined. And I just found it very unrealistic, and have talked to people with, we'll just say, good knowledge of Gartner, and when I've asked them, hey, has anybody actually developed any solution like this, they said no. So my experience and others' experience. So it may happen in the future. I'd love it to be able to do some of that magical stuff where it automatically incorporates, it learns what you're doing and when you've added new sources and ingest it, but it's not there yet. Maybe with ChatGPT, that'll be the next thing. But for now, I don't find their definition realistic. Das has, what is the product from Talon Data Fabric does? I don't know if I'm familiar with Talon's product in there. It could be it may be the data virtualization software on that. So with that, sometimes, which I don't like they do that, but some third parties will say, hey, you can create a data fabric by utilizing virtualization. So I have all these source systems everywhere. I put virtualization on top of it, and I have a data fabric. Now, but there's a lot of challenges with data virtualization software. So there are places for it, but if I'm going to do an enterprise solution, I'm going to try to avoid using data virtualization, because it just adds more cost and complexity to what I'm building in there. So I have some things in my blogs in there that go into data virtualization. When is it? What are the trade-offs of that? So you need to be aware of that. But anybody who comes out and says we can simplify your creating a data fabric just by using our product, I would take that with a big grain of salt. A grain of salt probably like that big, because there could be areas where it could be helpful, but it's not going. There are no shortcuts. I can't say that enough. Some of that stuff can help, but it's not going to suddenly make where I've seen claims of this, and instead of taking 10 months, you can take 10 days. And no, it doesn't work that way. It only will work for that way for a very specific use case, but it's going to fall flat once you started doing anything more elaborate. All right, so let me jump ahead and I'll go back and answer some of the questions I may have missed. So let's get into the data lakehouse. So the third architecture of 4. A 20-second history is we started out with a data lakehouse in a data warehouse in the 80s. If you think Teradata, then later Netezza, I can put all this data in a relational data warehouse. All this big data at the time was probably like maybe 1 terabyte, and it worked great in there. But as more and more data started getting ingested, even those technologies have improved, it still was challenging to incorporate and centralize all that data. Now, what came along was the idea was going to solve that problem was the data lake in the 2000s in there. And this was, if you remember, we had a few data lake Hadoop companies, MapR, and there was one that went out of business, and then we had my mind's going blank. There was a couple others in there, but 2 of the 3 went out of business. And the reason was because the way they approached and hyped a data lake was, hey, you don't need relational databases anymore. You can just land data in a data lake, and it's this land of unicorns and rainbows, and all the data will come out magically. And we're saving you all this time. And when I saw firsthand when customers, when I was talking to Microsoft, would come in and they're telling end users, hey, the data's in Hadoop, just go and use Hive SQL and go attach to those files and folders, and you get all the data and build your reports and that. And that didn't work well. And I have a lot of examples of customers that completely failed when they tried to use a data lake for everything. So what wound up happening in the succeeding years was we didn't get rid of the data lake. We just transitioned it into a more specific purpose, which I just talked about before. So the idea of using it for your staging tables and doing it for transformations, but doing it in combination with a relational data warehouse, which is what happened in the 2000s and 10s. That's the modern data warehouse I talked about. So a lot of success with that in the last half dozen years or so, or maybe 10 years. Will continue to be a lot of customers using the modern data warehouse on there. What's changed a few years ago, in particular from Databricks coming out with the data lake house concept, was, hey, let's go and put all our data in a data lake, and you don't need a relational data warehouse. And you're going to say, well, wait a minute, you just said that failed. Well, it did fail. And what's different now is the Delta Lake. So the idea is of a Delta Lake is we could add functionality on top of a data lake to make it more relational data warehouse-like, is the way I like to, as I want to say it. Delta Lake is not its own storage, it's just software. And the software put on top of a data lake gives you additional features, such things like ACID transactions, for those of you familiar with the relational database world. It adds time travel, which is a way to version the data in there. It's in one environment for streaming and batching the data. It has schema enforcement. So without this, if I have all these files in a folder and they're in a certain format, and somebody just goes and dumps something with a completely wrong format in there, my ETL is going to blow up. Delta Lake will kick that out and won't let it in there. So that's what schema enforcement it is. The biggest reason for Delta Lake is it supports delete, updates, and merge statements. With a data lake, those statements don't exist. You'd have to essentially load all the data in a file into memory and then go through it line by line and do your updates, and then write the whole file back out again and say this is a new version of that file in there. With a Delta Lake, you literally can use SQL statements that will go against a file in the Delta Lake format to allow you to do these deletes, updates, and merge. So it's relatively quick and gives you that support of the SQL statements in there. So this is a big reason, because I can do the data manipulation inside the data lake very quickly. And that is one thing that I don't have to do no longer in a data warehouse. Now, not that in the data warehouse you're doing a lot of updates and deletes. Mostly it's append, but it does give you the option to be have more flexibility, especially when you're doing things like incremental updates and stuff. There's a lot of performance improvements that come with the data lake. It solved the small file problem for those of you who are familiar with that. So a lot of great functionality that Delta Lake gives you, but and it's easy to use Delta format. If you're using, say, Spark, and you're writing, that statement I have on the right hand side is just change from instead of storing it as Parquet, you store it as Delta, which behind the scenes stores it in Parquet, but think of it as its own special way of storing it. So it gives you all this additional functionality. So a lot of customers are using Delta Lake. It's not the only type of product that can do this. There's Iceberg and Hoodoo or other Apache open source products that can do this, but they all essentially work the same and giving you additional functionality. Delta Lake has been open source, and they've come out with version 2.0 of it. So Databricks at first didn't open source all of it, but now they have. So Microsoft in particular has embraced Delta Lake, and all our products support it as the go-to way of giving this additional functionality. So this solves a couple of use cases where problems what you have with it, having both a data lake and a relational data warehouse is keeping them consistent could be a problem. If ETLs break, now you have one that's not equal to the other, and people can get different values, different reports for the same data if they're going against one or the other in there. In that modern data warehouse world, the data warehouse is always going to be older. So you solve that problem, one copy of the data, you don't have to worry about one being older than the other. It is required, is the preferred environment for data scientists is that file folder system. So instead of trying to force them onto a relational data warehouse where they don't like to build models off that, they can stay with the data lakehouse and do everything because all the data is going to be in there. And then even though storage is cheap, you're only having one copy of the data, so you save a little bit of money that way. So a lot of customers are looking into data lakehouse and I'm starting to implement it, but I'm going to open up a can of worms. Just with everything in life, there's trade-offs, and there are trade-offs with skipping a relational database. Speed, like I mentioned before, is if you want to run queries against a data lake or a Delta Lake, even though it's got performance improvements, you're generally not going to get the performance you have with a relational data warehouse because of technology like MPP, because of index statistics caching, query plans, ability to join tables and use those indexes, a lot more advanced than you find in a Delta Lake. Now, maybe that's not a concern. Maybe if it takes 5 seconds, you're like, oh, that's fine, I don't care. But if you need it to take milliseconds, then you're going to want to look at copying that data for that particular use case into a relational data warehouse, which in the Microsoft world would be a Synapse dedicated pool. As I mentioned before, there's no security of inside of a Delta Lake. So if you need that, there's some workarounds that are tough to implement. So it may be better to just copy that data into a relational data warehouse and use the RLS inside of that. As I talked about, the metadata is separate, so that's a big problem in a Delta Lake. Same problem exists. The metadata is not tied to it. It's not forced to be tied to it, so that can cause problems. Concurrency can be an issue a lot of times, trying to hit the same file where a number of users. Missing features like referential integrity don't exist in the Delta Lake. That may be important to you. If you use some of these features within a Delta Lake, you may be having to go to a Spark environment, which in itself cannot be a bad thing unless you have 100 end users who are used to T-SQL and now they have to be retrained. So maybe that in itself won't be a showstopper, but it's something to take consideration if you're going to forego a relational database. And products need to support the Delta Lake, which most do now, but that's something to keep in mind. And the last one is that force metadata layer I mentioned there. Now, with new technologies coming out, some of these concerns are going away. In particular, with Synapse, I touched on this before, you can create a view that points to a file sitting in a folder, and that view appears to be to the end user a relational database. So you're solving the problem of complexity, and you're also solving the problem of T-SQL, because once I create that view, they can use any T-SQL they want on that and not have to retrain them. And then if you're using Power BI, you can solve some of the problems with speed and roll-up security, because I can import that data from the Delta Lake into Power BI, which stores it in memory in this tabular model. I get millisecond response time. I have roll-level security built in there, and I can eliminate some of these concerns in there. And it may even save money because serverless, I have that view. I'm only paying per query, so that can be cheaper in there. So a lot of trade-offs to think about. So just be aware of those, and then decide if, hey, these are not a big deal. Let me go implement a data lakehouse. And I'm starting to tell customers, think of it as build a data lakehouse until you can't. If you get to a point where like, oh, well, this is a problem, I'm not getting the speed I need for this particular data set, just copy that one data set into a relational data warehouse and use it in that capacity in there, but you don't have to copy everything over. So it's not an either or. All right, so let me pause there. I can see we got a couple questions in there. Data fabric. Yeah, I'm going to skip over those questions in there because we're going to get off on a tangent, and I want to get to the data mesh, and I'll come back to those if we have time in there. But I appreciate the questions. Thanks. And if I don't get to them now, just send it to me afterwards. So let's jump into data mesh. Big topic, lot of hype. What's the genesis of what makes it different? It's everything I talked about is centralizing the data. It's copying it to a central location owned by IT, one data lake, one relational data warehouse. And the big difference in the data mesh is decentralization, is we're not copying everything in one location. We're not having IT ownership in that. And this is where it gets confusing, and I'll talk about it in a minute, but it's important to understand that data mesh is not technology. This is just a concept, which requires a huge organizational and cultural shift. So if you read the books on data mesh, they're not talking about technology. They're talking about how you can redo your company to implement a data mesh, which is not easy. It's extremely challenging in there. Now, the technology to build the data mesh will be what I've just talked about. It could be a data fabric or a data lakehouse in there, but data mesh itself is not related to technology at all. It's been getting a lot of hype. It's not something you can go and buy on eBay with a magic wand. There's no data mesh in a box. It requires a lot of work, more work than any of the architecture. So that's something that you need to understand up front. It's in this hype cycle. It's going up, and Gartner says 1 to 5% market penetration. That's probably optimistic in there. The point is, data mesh in itself is not bad. It's just not having the use cases for it that people are making it out to be. In short, data mesh is just made up of 4 principles. And this is it. This is simple. I've tried to make it simple, but believe me, I've probably taken me a year and a half at least to try to figure out what a data mesh is, because I keep going back to the original blogs that Gemma created, and it's not easy to make sense of it all. And so I tried to create this slide to make it easier by explaining the 4 principles that she talks about. One is domain ownership. The idea is, instead of copying all the data and IT owning the data in a central location, we have domains within our company, and we have to break it out in domains. So maybe we have manufacturing, sales, and supplier. Those domains own the data. So ownership is not transferred to IT. All those domains, which there could be hundreds of them, are the owners. With that comes the responsibility of treating data as a product, meaning each of those domains are going to have their own infrastructure, meaning they're going to have their own data lakes and data warehouses to keep their data. So they have all these OLTP systems. They're going to copy that data into their data lakes and data warehouses inside their domain, meaning they have to have their own IT team. They have to have that own infrastructure. They build it on it. And then they have to make it available for other domains to use, because other domains are going to want to have that data, or the consumer is going to want to have that data. How are they going to get it? Well, the domains have to create some platform, maybe API code, that is going to allow people to query the metadata and the data so everybody else can use it. So now the responsibility is taken out of IT and done into each of those domains. Well, to do that, imagine you have hundreds of domains. You don't want each of them going and building their own infrastructure. So principle 3 is that the company would create ideally a one-click script that you can press, and it's going to ask you a few questions. What's the name of your domain? What kind of storage and compute do you want? And boom, it builds it all out for you. Builds the storage, the compute, the ETL, the security on there. No product like that exists. No product like that will probably ever exist. Microsoft has things that will help a little bit in this area, but it's only a small percentage of what it's going to take to do this. This is one of the big problems of the data mesh, is that companies have to build this out their own, and it's very challenging to do that. And then the last principle for federated computational governance is the idea is, if I have all these domains building out their own infrastructure and owning the data, they have to follow some standards and guidelines. So I have to have a team that's going to give them these guidelines. So we can't have one domain going and using a security and another one using completely different security, and one following some data modeling and somebody doing it completely differently, and another one cleaning a data completely different than the others in there. So you have to have this centralized governing body that's going to give all domains this governance, and they're also going to monitor it, so make sure everybody's following that. So what you wind up with, and this is where it gets confusing, because data mesh is not like everything is decentralized. Some things are still centralized. In particular, the ownership and the data products are decentralized, but you're going to have some centralized infrastructure as a platform. Somebody's got to centralize that code, and then you're going to have that centralized governance on there. So this is where there's a mixture of the two, where people get confused. And when we look at the best use cases for data mesh is when it can solve these problems that your company may have. Maybe you have a lot of arguments over who owns the data. That problem goes away. It's the domain. The quality of data, because at least in theory, the people who know the data best are the domain owners, and they should be the ones that are cleaning the data. And then the biggest reasons are organizational scaling. If I have IT doing everything, I'm limited now by the IT people. So if I get more and more data, more and more bottleneck. If I instead break everything out to domains, each domain have their own IT team, I get more domains, no problem. I just hire more people and I scale out vertically in there instead of horizontally, which is what you're stuck with the other architectures in there. Boom, more domains, more people. Again, sounds easy in theory, and there's a lot of challenges to it. And that's what problem what people are having with data mesh. And then technical scaling, same thing is if IT is doing everything, they're limited to what they can scale from their existing hardware. If it's in the domains, each domain has their own team, they have their own storage and compute. More domains, more storage and compute. I'm solving the problem that way. How you keep it all aligned and all that is a whole other thing for a different day, but that's the problem we have with data domains in there. And a lot of customers spend a lot of time in data domain design, DDD, and they spend months to try to say, how are we going to break out all of these domains on there? So you have to do that before you even start thinking about building a data mesh. And what happens then is you have multiple domains. And one thing that came out of data mesh was having, because it could be complicated if you have a source aligned domain, meaning if I'm in manufacturing and I'm having manufactured people using my data and I create analytics for it, everybody in manufacturing may understand it all, but people outside that may go, I don't know what these terms mean. I'm confused. So what came out of the paper that Jamek wrote about this was, well, let's have a consumer line so we can take a copy of that data and make it more consumer friendly. And so that can be used for situations that need it for some of the domains. We also may have problems if I need to join multiple domains to create a P&L statement. It's going to be too slow to go and join all these domains with some query. So I need to copy the data into what she calls an aggregate domain, so I get the performance I need. Now, right away, I have problems with this because, well, then who owns this? And so we get back to the argument, and then now we're getting away from that decentralization to centralizing the data in there. So that's the problem. And so that's one of many problems I have with a data mesh. And I know I come across like I'm bashing data mesh, but there are a lot of problems and concerns you need to be aware of before you go and decide this is the path that you want to go down. So I just ask people to know about all these concerns. And if you say, look, it's not a big deal, then okay, go into data mesh. But a lot of times customers are going to have major problems with some of the things on here. For one of them, defining a data mesh, I often say you talk to 10 people about what a data mesh is, you'll get 11 different answers in there. And you have problems with this huge organizational change. If I am in a company and I go to a domain and say, hey, we've been taking your data and centralizing it, but we're changing it to a data mesh. So you keep your data, you hire an IT team, and you create a data lakes, and then you create APIs to make other domains access that data. and they go, that's a lot of extra work. I can barely keep the lights on. I don't want to do that. Why should I do that? And you say, well, for the greater good. They're going to go like, well, I don't really care for the greater good. If you want the data, go and take it. Now you have a problem with domains not listening to that. So how are you going to solve that? So there's a lot of issues you have with the data mesh. And even Jarek in her book says, should you adopt it? And she has this chart. And right away, this is going to eliminate 99% of companies, because if you don't score medium or higher in all these, you shouldn't use data mesh. Most customers are not early adopters. They're not domain oriented. They don't have long-term commitments. They're not tech at core. So this is where I just wanted to say that you have to be really knowledgeable about what a data mesh is. And with most customers, when they find out what a pure data mesh is, they're like, well, we're not going to do that. However, they like a lot of the concepts, and that brings up some great conversations about who owns the data and how to clean it and all these stuff. So while they may not build it as a pure data mesh, they may go a data lakehouse or use some combination of a data mesh. It does get customers talking a lot about how to get the most value of the data. So lastly, and I'll just mention because we're running out of time, is data mesh in Azure. There's not a lot of slides to this because, again, data mesh is not technology. It's concepts, and it's those four principles. And you can even argue about, and I see this a lot with customers, well, if I build a data mesh, can I call it data mesh if I use 3 of the principles or 2 of the principles? A lot of customers will use 1 and 2, but not 3 and 4 of the principles. And this is where we get a confusion. And I've seen customers, virtualization software customers go, just put virtualization software on it and you have a data mesh. Well, you're not following any 4 of the principles, so you can't call it a data mesh. So this is where it's getting confusing. So what Microsoft has done to try to help, at least with principle 3 and somewhat with 4, is this thing called cloud scale analytics. It's a shortcut to building a data mesh, which is going to take you 2 or 3 times longer than building out those other architectures that we talked about. But to cut down a bit on that time, this is a script that you can run to build out your environment on there. This script can also be used for data lakehouses, things that are centralized, but it's a shortcut for the domains to build out architectures. So you could have one data management landing zone that is used for everything. Within that, you have multiple data landing zones, one for each domain, that can be more quickly built using cloud scale analytics on there. And what we see, this will be the last slide, is data mesh types. And this is where, if you're building out something automated in there, you're generally going to follow what I call mesh type 1, is that everybody's going to use the same technology. And what the cloud scale analytics does is, instead of each domain having their own data lake, you have a centralized data lake, physically centralized, but logically separated by folders. So each domain has their own folder that only they have access to. So it's a logical separation, but not a physical one. So that can cut down on the performance problems and the governance problems by doing it that way. Going to mesh type 2 is all domains are using the same technology, but each domain also has its own storage, which means you now run into the problem of how you connect all this storage. If consumers need to combine data from more than one domain, which they are. So I do see some companies using it this way. This could be where virtualization software comes into play, but they're still very challenging to get the performance you need out of this. And then mesh type 3, which I don't think we'll ever see, is any domain can use whatever technology they want, whatever storage they want. So imagine a domain, I'm going to use Google, I'm going to use Amazon, I'm going to use an Azure. Even within Azure, I can say I'm going to use SQL database, I'm going to use Synapse, use Cosmos DB. It's going to be a complete mess. Principle 3, to automate that would be impossible. And then governance, because now you have completely different security mechanisms on there. So I don't see this ideal version of a data mesh ever coming true, just because of the huge complexity. And then, well, this is the final slide. Is my future is think you'll see some combination of this. You'll have companies who already built a centralized solution now incorporate other types of data, and they will build a data mesh for that. So maybe they have a new group and they want that group to build out what they're doing in the data mesh, and that will be used in combination of a centralized solution. Because all it takes is one to say, I'm not going to go with this data mesh, and you're forced into this. And so maybe you can take some of that centralized and make it part of a data mesh over time, but I don't think it'll be very rare that you'll see anybody using a complete data mesh. All right, a lot of talking on there. There's some more resources that'll be available in the deck that I'll send out. And then I'm going much more deeper into a book on this very topic. So expect to see that in a couple of months. Hopefully you'll find that valuable. And then if you have any questions, you can come off mute here. I know we're out of time, I apologize, or send me questions directly on that. So with that, anybody wants to come off mute, happy to have you. I can also look at the chat and answer those. All right. One question is, have you seen clients adopt data mesh in the last 2 years? So I have to say yes. We're not talking about a ton of companies, but Microsoft is having success. Where I find in almost every case is, I do find in every case is nobody has a pure data mesh. There are always some exceptions to it. So again, can you still call it a data mesh if you're following 3 other principles or 2? If you want to use that term, fine. But this is where it's a big gray area on there. And there are a lot of ways of creating what you can still call a data mesh without following all those principles and still getting a lot of value out of it. The companies that are building it tend to be very large companies, mainly financial, who are separated into data domains by nature. So it's not a lot of work for them compared to other companies, but it's a 2 and a 3 year process for companies to build out data mesh. So they are out there. There's just not a lot of them. Let's see. Let me go to one more, and if people need to drop off, I completely understand.
Looks like you have a question from Ramesh.
Yes. Yeah, go ahead.
He's got his hand
Ramesh.
up there, Ramesh. Don't know if that's a leftover hand or the hand is down.
The hand is down. Yeah. So I'll pick up another one in here that we had to end with. What is data virtualization in the context of data lake? So data virtualization is just creating a connectors to all your data that could be sitting in your data lake, and it pulls out the metadata and creates a single entry point like a data catalog that you can use to query all that data. And this becomes very useful in situations where you can't take data out of a country because of requirements on there. So what I can do is I can have multiple data lakes, and then I can put virtualization software on there, and that virtualization software can check if somebody is already in that country before it lets them go and access that data. Or it could be a quick and dirty way to get access to a data without copying it over. And with virtualization software, you'll have to go through that entry point, that catalog, and then you can go and run queries off that and not have to be aware of what technology you use behind the scenes. Somebody did the upfront work to connect all those data lakes and create that data catalog, and then you can query off that. And that can work very well as long as you are following what the querying of data that is expected, because they can cache the data and you get performance you need on there. Because imagine you're pulling data from 20 different sources that are all over the whole country or whole world. The performance would be terrible if you didn't have caching. So it'll cache the data, but then once you request data outside of that cache, now you run into a performance hit. So a lot of pros and cons with data virtualization, but they can be even be used for ETL on there. I can create a path to this data lake and use the virtualization software instead of an ETL tool to pull data over, and I see that happen sometimes. All right, so I will answer one more. Is there, do you see more success with data fabric versus on pure data mesh implementations in there? Customers who implement both data fabric and data mesh at the same time. So the customers implementing data mesh are using data fabrics underneath the covers in there. Each domain will have its data fabric, or we call it a modern data warehouse, or call it a data lake house. They'll be using one of those 3 architectures. So you can have a lot of those architectures inside of a data mesh broken out by each domain in there. And so that is where I see customers going in there. And in the ideal world, you wouldn't, and this is one thing I don't like about data mesh, is that people say, well, you don't need data lakes or data warehouse anymore because you can just go against the source system. And a lot of times they have a copy of the data automatically, and you just query off that and you avoid the stress. Well, I can go on for a long time saying that's not a good idea. And for many reasons, goes back to the first slide of data warehouse. Also, I have customers who are still using mainframe. So to think that you can just go and attach and query that data and forget it, it's not going to happen in there. So that's where a lot of people think too highly of the data mesh, because they hear some of this hype and they think, oh, I don't need a data lake or data warehouse anymore. And that's where I have to fight back up and educate customers otherwise. All right. So again, if I missed a question, there's my email, send it out to me. Happy to talk about that. Happy to hop on a call and go over this. This is stuff I'm passionate about. This, I love talking about it. I love trying to clear up the confusion because it is very confusing on there. Hopefully I've done that today. And if you want to follow up, just shoot me an email.
Thank you so much, James, for the information. If you want to send the presentation to our group, we can put that up on our meetups just to make sure that everybody gets a copy of it.
I'll do that.
That was a really informative session. I think at one point I saw 66 people on, so a lot of people interested. So just keep an eye out for James's presentation. His contact information will be in there. I know there was a few other questions, so take him up on his offer to get that information from him. And also thank you, Tamantha, for reminding us about this session and getting everybody to sign up. And we look forward to having everybody join us for the March session. And once again, thank you so much, James, for spending the time with us this evening.
Happy to do it.
All right.
Thanks,
have a good
everyone.
night, everybody.
Okay. Bye.
Thank you. Thank you, everyone. Thank you so much, James.
Thank you.